Hello, my name is Avi Freedman, and we're going to continue talking about BGP. I think we have much of the audience from the first presentation. In the first presentation, talking about more BGP basics, it looked like almost everyone in the audience had at least a few routers up and running and doing BGP, a little bit of experience moving traffic back and forth, some address space, a mix of routers, although at least half of the audience didn't actually admit what kind of routers they have. But a lot of people had not gotten to the point of implementing route reflection in their network. How many people use communities in their network to tag routes as they hear them? And how many people have used their provider's community list to do route filtering? And how many people have used their provider's community list to change how their routes are heard by third-party networks? Okay, cool. So again, it looks like a lot of this will be old news for some people, but we will go through it. The talk got called BGP 201. This is a little bit more 102, but I think that we'll have some time at the end for some questions. And because it sounded like a lot of people in the audience knew how to use screen and knew how to use the TypeScript command and turlen 0, but had never actually taken a BGP dump and manhandled it with Perl. So I'll actually do a demo of that and write some Perl live while I get heckled. So BGP is pretty easy to get configured and basically working. It's actually also not even that hard to get complaints and have someone say, oh, my UUnit connectivity is sucking through Cogent, let me change that. Let me change where I send that. It gets a little bit more difficult to scale because of the way the protocol was designed, things like having to have the full iBGP mesh and having to build filter lists that specifically list every AS and route. It gets very difficult to do the way that works fine at the small level as you go to 5, 10 routers, tens or hundreds of customers. So there are some things that are pretty old school, but a little bit beyond the first implementation of BGP that help scaling. So we'll talk about communities, route reflection. I include Confederations just to drive other people crazy because no one uses it anymore, but it's actually interesting to think about. I think it helps understand some of the ways that you can scale BGP and why route reflectors are nice to look at Confederations. Local-Pref and some security and scalability issues. So there is a review of BGP. I'm going to basically skip over that because I think that most of the people were here in the last one, and this is BGP 102 anyway. I talked about routes. So talk a little bit more about stable routing and scaling with loopbacks. So in the last, in 101, we talked about how when you create BGP routes, you want to actually have, you really should have, a static route or an IGP route that underlies the BGP route so that if the interface that you happen to have that route on goes down, you don't stop advertising the BGP route. If you're the only way to get there, you want to keep that route advertised. You don't want there to be connectivity problems. And most importantly, the world at large does not want to hear your flapping for some interface going up or down. Similarly, BGP sessions themselves being tied to interfaces can cause extra stability when Mr. Knock Monkey walks past and jiggles the cable, or the optic is going slightly flaky, and you actually can have intermittent outages in the interface. You should be detecting that by monitoring it anyway, but you don't actually want the BGP sessions to go down. The last presentation we talked about, inside the router, there's BGP routing table, OSPF routing table, static routing table, the IP routing table, the forwarding table on each line card. Every time you kill a BGP session, packets die. Sorry. Every time you kill a BGP session, all of the routes have to be withdrawn from your table. If you've advertised them to anyone, they need to be withdrawn from other routers from sessions. If they were the best BGP route, they need to be withdrawn potentially from the IP routing table, from the line cards. There's a lot of work that goes on. So you want to eliminate flapping in your network. So loopbacks helps with that, since the loopbacks don't go down. And it can also be good for load balancing. Using BGP loopbacks can be good for load balancing. You can have a bunch of physical links and do multipath routing is one of the ways that you can do it if you don't use LACP or Ether channel or things like that. You can have loopbacks that actually span links and have your IGP do load spreading. So you set up a loopback interface, and then you use the update source of a loopback interface to actually make the BGP session not be between the IP address of the interface, but actually loopbacks. And what that gets you is, if there's problems with one of the underlying interfaces, IGP will not use that path if you're doing load balancing, but your IGP will take it out, but the BGP session will stay up. And that's important for making sure that you have stability in your network. Another nice thing is, if you have a consistent loopback scheme, as you start growing from 2 to 3 to 4 routers, just like you can grow to recognize the autonomous system numbers by, in a show IP BGP, you can grow to recognize the loopback IP addresses of the different routers as you look at things. So as you look at the output of different commands and see what's going on, you can, by inspection, look and see, oh, I know that's that router there. As you do iBGP meshes, it's also nice if you number your routers from 1 to whatever, you can actually just, by inspection, make sure that you've listed them all. Same thing by monitoring. You don't really want to be, as you scale, remembering one particular Ethernet interface of the management of a router when you SNMP it. You want to have something that you can expose access to, lock down, use to get into canonically, and routes too. It's good for logging and TACACs, and again, it makes it very easy to do consistent configuration if you have a net block that everything gets put in for your loopbacks. So, another feature in terms of stability is supporting route refresh, dynamic reconfig. It's better than soft reconfig. One of the challenges with soft reconfiguration, which we talked about in the last presentation, is that if you actually want to be able to reapply a BGP policy, you have a new route map, filters, whatever, and you want to reapply it, then you need to clear IP BGP. You need to tell it that it needs to apply to the interface. Now, if you actually kill it, if you do that without saying soft reconfig, then it's actually going to kill the BGP session, which you don't want to do. But the only way that routers used to have to be able to support this kind of feature, the ability to change the policy and have it take effect without killing the BGP session, was to keep a copy of all the routes that had been advertised, or to tag them in RAM that they had been advertised. The problem is, what if you're fighting a situation where someone has advertised a whole bunch of routes that should never be there on the internet, like a deaggregation scenario, or what if you're doing the deaggregation? You can actually have a lot of RAM be occupied for routes that you want to be long gone and forgotten about. With routing code that supports route refresh, you effectively do the same syntax of soft clearing, but you don't actually have to have stored all of the old state, because you can have the routers will actually communicate that efficiently. Typically, and you can look at it, you can do show IP BGP neighbor and see what things are supported and make sure that route refresh is supported. And using soft reconfig will do the same thing, but will fall back to it typically. It just uses a little bit more RAM. Typically, the limiting factor for most people that most people worry about on routers nowadays is the hardware forwarding table capacity. Usually, it's pretty easy to put enough RAM in that the RAM itself isn't an issue, but every 5 or 10 years, it sort of swaps which is more important, the actual DRAM in the router or not. Typically, the rule of thumb is the biggest, baddest core router that you can buy has the RAM and CPU of the medium-sized Macintosh from 5 years prior. So if you look back over the last 20 years, that's pretty much followed. So you still typically don't see things with octa-core 72 gig Nehalem's in the core routing. And hopefully that won't be needed as the deaggregation incident ensues as the market space in IPv4 explodes the routing tables in the next few years. So soft reconfig, again, low CPU uses some RAM, but really very important to enable it because you don't want to be hard clearing your BGP sessions. Not only will you be having tons of CPU problems and packets dropping, but also if your routes, if you stop advertising your route to the outside world, then there'll be reachability problems coming back into you. The simplest method is BGP passwords, which apply actually on the TCP session. A lot of people don't like that. and you can get pretty much the same benefit from using the TTL hack. The arguments against BGP passwords go, no one's ever really shown BGP being hijacked by people breaking TCP or even just BGP sessions interrupted. And a lot of people don't like having to negotiate and track and deal with passwords in the negotiation process. But definitely should do BGP TTL if you're not doing other kinds of filtering to make sure that BGP packets can't get in except from your neighbors. There are just because in general, the bad guys who are attacking the internet infrastructure actually need the internet to work, but one never knows when you might set some IRC kitty or one of your employees might be that IRC kitty, and someone might have a thing for your network and you might get a ton of packets. It's best to make sure that at the TCP layer, at the filtering layer, that your router CPU doesn't have to worry about things that aren't from your neighbors. So, max prefix filtering, also definitely a good thing to do. Some people have more complicated software that actually tries to figure out when their peers are sending them garbage. That's very difficult because there is no authoritative database of what the world should be like in BGP. But at least trying to make sure that your 2-prefix customer doesn't send you 10,000 routes is a good place to start. There are a couple of different failure modes that you can have it do. You can have it notify you. You can have it kill the session. So you want to be careful about that. You definitely, if you use this, want to have logging enabled. It sounded in the last presentation like most people do know about syslog and having their routers log BGP events to something that people look at least every day, if not every hour, or in semi-real time. So enabling max prefix filtering is probably a pretty good idea, and networks generally don't change their size massively overnight. Except for Carpathia, but even that wasn't number of routes. That was just total traffic spewed out various ports. So pretty easy to do. Logging you really want to do. It's pretty important to be able to see, hopefully you're noticing, actually I'll just ask the question, how many people do regularly look at the switch errors and interface errors that they're seeing across their whole network? Okay. How many people use the traffic data and say set thresholds that if traffic goes above or below a certain amount, they'll alert customers or peers or send that to salespeople to upsell their customers? So often a very small rate of incrementing of interface errors can actually cause noticeable BGP problems, which you don't see until you look at it. So it's very common to see something that's a couple of interface errors an hour, but every hour you wind up having the BGP session drop and restart. And in many cases, it's an internal session or it's a session with a customer. It doesn't affect you that much, but eventually those things always turn into complaints, and it's easier to nip them in the bud. So if you wind up only having a syslog infrastructure that has way too much stuff with systems, set up a separate box. I assume most people have a virtualization infrastructure, so it'd be pretty easy to do, just to grab the BGP logging data out of your router. Peer groups is another thing that is pretty ancient by now, but was added to BGP as a scaling functionality. They were not designed to save typing. It was designed to be able to say, if I have routes that are going to 10 different people, and they're always the same, and all the attributes in those routes are the same, let me create them once so I can then enqueue them on a bunch of different sessions and save the CPU. So this was more back in the days of the routing processors were fast 60-40s and relatively slow RISC processors, but it also does save typing. The major caveat is basically all of the attributes have to be the same. So it also ties to having the same policy. So if you have very similar policy towards a bunch of people, then you can use peer groups. You can do it. You can try doing it for different customers, but at that point, you might as well just have different kinds of configs. Next hop is one of the attributes. So if you actually have many different interfaces, then it can be complicated to try to set peer group. And I don't even know, I haven't tried it recently to see what the behavior is if you try to actually do it with multiple peers on multiple external interfaces. I guess that would be interesting to see. So it's useful for eBGP peers, but sometimes not for iBGP peers. And you can still express different inbound policy. It's really only that the outbound sets of attributes have to be the same. So sample peer group, if you're peering with a bunch of people on a common interface, you've got a route map that says what you do with the routes that you get. You've got the route map that does the same thing when you advertise. It's just my routes, and I sanitize next hop and such. And I have a bogon filter in, and I apply it to everybody, and it saves me some typing. And the routes that are going outbound, I only have to run through my routing table once for all of those peers, and so it saves me some CPU as well. So when you start getting into having BGP customers, and you have been in a mode where when you turn on customers, you have an IP access list and an AS path access list, or a prefix list and an AS list that you update every time you have a customer, you have to update that on all your external interfaces. So everyone that you peer with, everyone that you get transit from, you have to update every time a customer updates their routing list, their route list. And that becomes problematic because it's just, well, it doesn't scale well, as VJ would say. Instead, what you really want to be able to do is at the place where you speak to the customer on that interface, on that peering session, be able to express the policy and say, the routes that I hear from here, I will only accept in this list, and the routes that I do accept, I must treat them as my most highest preferred customer routes because they're paying me, or they're a peer and I will never re-advertise them, or tag them with communities and say, I heard them in Ashburn, or I heard them over a private interconnect. And instead of applying that at the edge of your network, it actually scales better to apply it where you actually hear from the customer. So the BGP mechanism for doing that is communities. So again, a scale issue. BGP communities are just a number. Someone asked me a question which I do not know the answer to, which is, how are community widths changing with 4-byte ASs and such? So presumably someone in the audience will know. But it gives you an easier control of where routes goes. They're just numbers that you put onto the BGP routes, and they mean whatever humans decide they mean. There's no canonical well-known except for a very few well-known communities. Typically, you group them into 2 bytes colon 2 bytes. So I might say, I am 6450, and I put a number on it that means that I heard it in Ashburn, so 6450 colon 30, and I tell people that's what it means. Or I might internally have 6450 colon 999 means that it's a customer route, and then based on that, I set my local pref high. So communities by default are not sent to external peers, but you can make them be sent by saying send communities. And an example of what you might do is if I know it's a customer, then in the route map that I apply to them, I'd say set community colon 1200 additive. If you don't say additive, it will wipe out the communities that they had been trying to send me, maybe. And then later on, based on that, I might talk to a peer and have a route map that says, I'm going to send the route if it's in IP community list 4, and in 4, I look for the community that says it is transit. So at the edge, I put 4969 colon 1200 on it, if it's a customer. I'm sorry, at the customer edge, and at the peering edge, I look for that community on the route, and if it's there, then I send it. And typically that community list would be different. I might have 3 or 4 communities that are routes that I would send. So another thing that you can do with communities is not just use it internally to say, oh, on this peering session, these routes that I accept, they are customer routes, and I will tag them and maybe set the local pref high. You can also use it so that when a customer says, gee, I really want to be seen as being further away from UUNet when I advertise the route through you. Well, they have no way of doing that because they don't connect to UUNet. You connect to UUNet. You can use communities to allow customers to tell you how to handle their routes. Now, you don't have to do anything. They're only going to be able to use communities if you create a community policy set and you implement it in your routers and you tell them what the communities are. I guess you can reverse engineer. How many people have spent over 4 hours of their life reverse engineering other people's community systems? Okay. Over 24 hours? Written programs to do regression? No. Okay. So hopefully people will tell you, and typically, you know, best practice is that you probably shouldn't be buying from anyone that doesn't have at least a minimal community list and expose it to you. You know, hopefully before you're a customer, so you can look at it. Sometimes at least after you're a customer. We should put the URL, and I think Raz did a good presentation on coming up with a sane community system. Lots of regex and complicated things that normally make my eyes bleed unless I sit down and focus on it. But copy and paste is a good one. There's no royalties for the end layer community system. So an example might be 4969:12392 might mean pad 1239 twice. In the old days, you would make specific communities because someone would ask for it. The newer method is to actually come up with a flexible system that's very regular that you can apply. And if you're actually generating router configs, your entire system can be embedded in the router configs as you generate them. And your customers can apply them to any AS that you might peer with, whether or not you, by hand, created it. So scaling-wise, that's important. But you have a lot of flexibility. Oh, we actually do. Sorry, it is not rendering well. So an example is nlayer.net BGP Communities. And then if you search for Steam version, then I think number 80 of 236 on the Nanog presentation list is the community system that Richard gave. So, scaling with Local-Prefs, we talked about this a little bit in the last presentation, but if you're trying to influence how your outbound traffic goes, and you don't want to have a fleet of monkeys typing static routes in, and you don't buy a magic route science or internet box, then typically what happens is people complain. You notice that you have poor connectivity to a given destination. You say, oh, those are all inside AS 99, 999, whatever. And you say, oh, well, I've got A and B, and right now, show IP BGP reg 99, that's going out A. Let me try to make it go through B. And you can either do that by preffing it through B or depreffing it through A. And you can either do that by making it look a little bit further away in the AS path, which is the primary way that BGP is going to tie break if you just turn it on and get multiple BGP feeds. Or you can use Local-Prefs. And you can use pretty complex policy by doing this, what's called AS path padding, making a path look further away by matching on it and saying set AS path prepend with an AS number, makes it look a little bit less good. You can append 2, 3, 4, 5 times. You can do really weird things where you can append other people's ASs on the outbound side. I would recommend that you don't do that, or you may get people upset at you. But if you're just trying internally to make a path look further, you can do that. The problem is, how many people have downstream BGP customers? So your customers probably don't want that, don't want to see that, because there's no set AS depend, whatever the word is, depends for your BGP routes. There's nothing to subtract AS hops, and that's important because loop detection it depends on the AS path accurately describing everywhere that the route has been. So guaranteed, if you had the ability to do that, some crazy person would use it for something inappropriate, and you'd have routing loops all over the internet, and that would be bad. So AS path padding, there is a reason why people philosophically like using it, which is if I'm trying to adjust my inbound bandwidth, I may try to make something look further away by AS path padding outside. That's me signaling at the edge of the internet, hey, I like A more than B. And if everything stays in the AS path padding realm, then I can pay attention to that and modify it a little bit. But if you have to redistribute BGP, you don't want to mess up the AS paths. Your customers won't like it because they're trying to do load balancing. So the answer is Local-Pref. Local-Pref is a pretty powerful BGP attribute. It's not as important as the weight in terms of path selection, but you shouldn't be using the weight attribute anyway. but it does come before AS path length. So if you set the local pref, it'll override AS path. The most important thing is to come up with a scheme up front. Think about routes you might not like, routes you might like reasonably well, the ones I pay for. Typically, I would leave at 100. The normal routes that BGP would be selecting anyway are already at effectively 100. If there is no local pref community, then it's as if the local pref community, not community, attribute, then it's as if there was a local pref attribute there with the value of 100. So if you do a show IP BGP, you'll see 100 and then blank. The blank is the same as being 100. So normally you might leave that, but let's say you want to depref. Now you might use less than 100. Now let's say that you've got something in the transit range that you might prefer. You might reserve 110, 120, something like that for that. The most important thing is that you have to leave room for customer routes to always unambiguously be higher than anything that you get from transit. Biggest problem that I've seen with weird customer advertisements is someone goes in and needs to change external traffic, and they apply a high local pref on a transit link just for a given AS or something, and it winds up being higher than the local pref that they apply to customers. The highest local pref wins. If you prefer external routes above a customer, you can't advertise that customer's route to anyone, and you pretty quickly find out there's a problem. On the other hand, you might not quickly find out. It may be a multi-homed customer, and it's only when their other link goes down that anyone notices that there's a problem. So the important thing is plan it in advance. So you might know that in less than 100 is the preferred routes. 100 might be my peer routes. And I might have a range for things that I peer with and things that are private interconnects, interconnects that are sucking, transit pipes, private cross connects might be higher than transit because of cost. And then customer routes, I always want to keep at a certain high level. So not quite as complex as a community system, but you definitely want to have that thought out and have it documented on your routing wiki, wherever you document such institutional knowledge, and be able to implement it. So we've got communities that I can use instead of having to edit filters on every one external link. And now we've got local prefs that I can use to be able to make sure that I prefer the routes properly. So I can now have route maps that say, when I'm peering with someone at a public IX that I don't have any special reason to love, I set the local pref to 100, and then I apply, let's say 8100 Boone is where I peer. I make a community that says, hey, this came from 8100 Boone Boulevard, and then I've got a attribute 666 that says it's from the outside world. A lot of people use 666 to mean not me, just some random outside place. PNI 125, I might say if it's a private interconnect, I heard it, in some POP 609. It's an external route, but I'm going to set the local pref higher. And then if it's a customer, then I'm going to do a couple things. I'm going to make sure the local pref is the highest, and I'm also going to set a community, that 1200, which elsewhere I'm going to use to say, oh, if community 1200 is set, then it's my customer. I'll always advertise them to someone. And there, because that customer might be giving me other communities that I might use in other ways, I'm going to say additive, because I want to make sure that I don't blow away whatever they might have told me. I'm going to talk about a couple of ways of scaling the iBGP mesh. In the last presentation, we talked a little bit about this. The basic problem is iBGP is very promiscuous. eBGP is very promiscuous, and iBGP is not. So in eBGP, the default is give everyone everything and accept everything from everyone. In iBGP, there's some limitations. You can't advertise an internal route that you heard from a third party to another router. And the reason for that is there's no way to do loop detection. So you just keep advertising the routes again, around and around. So ideally, what would have happened was they would have had an attribute for doing loop detection for iBGP in the beginning, but they didn't. So there are a couple of approaches that developed for being able to deal with the scalability problem. And the scalability problem is you don't want to have, if you have 50 routers, every router talk to every other router in an iBGP mesh. So these rules are counterintuitive, but ultimately you don't want to have to wind up with satanic diagrams of every router appearing with every other router. So the two approaches are confederations and route reflectors. I'm actually going to edit this presentation here. Older presentation. And route reflectors are the more commonly used method. It's interesting to look at confederations because it's just another way of thinking about and understanding the iBGP limitation. So with confederations, what happens is iBGP becomes more promiscuous. It sort of becomes schizophrenic. You configure BGP so that it looks like every POP has a different autonomous system number, but in reality, there's a nudge, nudge, wink, wink that they know that they're all part of the same network. So within a POP, all the BGP speakers talk to each other in a full mesh. Every POP is actually router BGP and then some fake AS, reserved AS 64512 and above. Well, below 4 byte, but it was 65535. And then between POPs, they use eBGP rules. So even though the AS numbers are different when they peer, they use the eBGP rules, so they send Local-Pref, et cetera. And within POPs, use iBGP rules. But between POPs, they actually send all the routes. So they don't worry about loop detection because they can do loop detection in the AS path because every POP has its own autonomous system. But you preserve Local-Prefs. So what it looks like is pentagrams in your network with full mesh inside each POP and then peering. But 64512 and 64513 really know they're part of the same AS. They're just pretending not to be for the sake of clarity. It gives you some interesting fallout in that when you look at your autonomous system paths internally, you can actually see how the route has been traveling, and there's some interesting consequences there. And it also helps sort of understand how you can, the hierarchical nature of how you get around the scalability problem. But most people don't use confederations anymore. You have trickier AS paths. You have to do real, because you have parentheses and you have to do all sorts of regex, and people don't like it. It does give you the ability to do some interesting traffic engineering. If anyone's interested in some examples of that, we could talk about it at some point, but really MPLS is the way to go, and route reflectors in general, if nothing else, just because the people that you're going to hire are going to be familiar with those technologies. Does anyone run confederations in the network? Okay. So maybe we'll take that out in the future. So route reflectors is another way of solving the scalability problem. And again, the problem is, how do you do loop detection? So you nominate one or two routers in a cluster, which is often a POP, or it could be more than a POP, to be allowed to break the rules for their clients and reflect these routes that are these third-party internal routes to each other. And obviously what you have to do is they actually have to have a way to tag how to do the loop detection, and that's what route reflector am I using, and the route reflector keeps track of it. So the iBGP routes heard from non-clients are sent to clients, but not other non-clients, so it does reflection internally. And eBGP works like normal, and then you fully mesh the route reflectors. So you actually do wind up with something that looks similar to the confederations, except typically fewer BGP sessions externally, and in some cases you might have one route reflector for your whole network or for a POP, and then the route reflectors themselves are fully meshed. So on the server, you tag each client so that it knows that it's a client and it can break the rules. And all the route reflector servers still have to peer with each other because they're just running iBGP, between each other, and you need to get those routes out. One caveat on a lot of implementations, enabling this will reset the session because it actually has to apply new attributes to the routes to track this all. Originator ID gets applied, which is how it knows what route reflector is sort of the master that heard it, and cluster list, which is sort of like in the confederations where you have the fake AS numbers. It's sort of how did the route propagate. So when you look at the route, you can still figure out some of the topology information about what's going on in your network. So how many people are planning on implementing route reflectors in the next maintenance window? How many people have thought about implementing route reflectors in the next year? Okay, so supporting multi-home customers. What they're really looking from you is some enlightenment and support in being able to do what they need to do, which is your multi-home customers now have their customers. Sort of like one of the things that you learned pretty early on is when your customer is screaming at you because you have an outage, they've got customers screaming at them, and in some cases they've got customers screaming at them. So the reason why sometimes it's better to have an outage last longer and do better communication is because people go much less apeshit, especially at contract renewal time, if they can actually tell people something, even if it's completely made up, about what's going on and how long it's going to take to resolve things, than if they're just sitting there with people calling them and they have nothing intelligent to say, other than making something up that would presumably be less intelligent than whatever you would make up, because you read release notes and are much more familiar with real Cisco things that you could blame, different vendors on. So another thing is they're going to talk to you about advertising routes. How do I do that? They're going to want to be able to change traffic and pref it, which means community system and being able to implement it. If you implement communities and then you stop supporting certain things, you need to warn your customers and make sure that you do that. Generally, people are pretty good about that, and having a regularized community system is the easiest way to make sure that you don't have people manually creating and deleting communities, that apply in different places in your network. For these multi-home customers, you're going to have people that you give address space who are going to start along the path and not have their own address space, and you're going to need to announce some of your address space more specifically. So if you do create routes into BGP from redistribution, that'll be a little bit of a trick. With network statements, it's not that hard. And again, implementing communities. Interesting thing that I don't see as much of anymore, I used to see more of it. Nowadays, a lot of people do, multi-homing is much more cost effective, is backup transit. So this was something that tripped up the early BGP researchers, because there are a set of people who can vary infinitely from the expected use of BGP based on severe economic considerations. Mashed potato routing and all sorts of other things that happen because you're trying to save money, you're trying to implement redundancy. And one of the things that you can often find is another provider that might be technically competing with you, but not really head-on, you're wholesale, they're retail, that you can do backup transit with. Especially if you're in a Equinix-type data center, there's often people that you can establish those links with, so that if you have two providers or one provider, you guys each can give each other a link that's there for redundancy, so at least if shit hits the fan, you can call each other, and you can always have the option to turn something up and give each other some flexible connectivity. So being able to support that is something that you'll typically want to be able to use communities, so that if someone temporarily needs to borrow a cup of transit, you give them communities that can apply to the route that will turn the session from peering into transit and then back. And you may want to have a policy, and you may charge or you may not charge, but some of the techniques that you can use to support customers can also give you more diversity in your network. Or you could just get a whole bunch of WiMAX and get some GRE tunnels and hope that all your customers can shrink down to 10 megabits for the period of time that you're down. So, how do you log config changes? How many people run Rancid? How many people run something like Rancid to track their config changes, but not Rancid properly? Very useful to use something that diffs your router configs. It's very useful if you have more than one person. Even if you don't have more than one person, it can be useful. It was great if you're in a team of 3, 4, 5 people, someone goes on vacation, they can come back and catch up on everything that changed. You can have some senior guys monitoring to make sure that the tickets that were supposed to be done overnight to change some static routes, that there's no OSPF that magically changed for some reason that no one knows about. Does Rancid now actually come with hooks to look at TACAX logs, or do you have to write that? Okay, so there are a bunch of networks that I've worked with where I've actually written some custom code to the Rancid reports actually look at the TACAX logs to show you who changed every line. So if there's something weird, you actually know exactly who to talk to without having to go back and grab. That can be interesting. So getting some sort of regular process involved is nice. How many people have the Holy Grail, which is to say configurations get pushed through a central management system that then detects policy violations and, okay, no one. Yeah, some people would, how many people would like to have a system that they use to configure their network? Okay, so sort of interesting in the cloud space where I play a little bit is trying to do that for machines as well, especially the people that are, the real holy grail is the people trying to do that for Windows machines. But, The ideal is that everything on your network is configured according to some canonical policy database, rather than the database being assembled from whatever randomly got typed into the network. If in some larger companies, they actually have Sarbanes-Oxley constraints, and basically all the auditors are completely ignoring the fact that no one knows what the network should look like. And if you think it's bad that, I mean, you know, it follows from the fact that no one knows what any local network should look like. It shouldn't be surprising that no one knows what the internet should look like. So you're looking at it and you just know that it's a mess, but you don't know exactly why or how. So the more regular you can get, the better off you'll be. The fewer customer complaints, the less time you'll spend, you know, reviewing configs and wondering why something was. So some things you'd probably want to have in your configs is have some users, have some TACX servers that you talk to. Now, a downside is if you do log every command, then the thing that will drive you crazy, if you lose connectivity to your TACX server, then every time you type a command and it can't connect, you may have a few second delay, and that can be a little bit annoying. So if you have a connectivity problem, the first thing you may need to do is turn off logging. One other thing I'll say, based on some actual experience about 10 years ago, is do not let the people who have enable on your routers have root on the machines that audit the routers, or when someone types redistribute, you know, A into B and their network blows up, the first thing they'll do is go out of band to the logging server and crash it, or, you know, kill those lines in the log. So audit can actually be useful for, at least for training purposes, if not for extreme sanction. So let's say you have a sample network, you've got different POPs, you've got some more tightly clustered than others. You've got a POP that will look at, say, an Ashburn with some customers, core router, some direct connection switches. I'd say, let's say this is an organically evolved network. On the side, I run one such organically evolved network. If I had had more time and my wife had not gotten sick, I was going to take a victim SOUP2 catalyst and actually do some load balancing with some crappy traffic that we support. But that'll have to be next NANOG, where we actually do victimization of traffic for people for demonstration purposes. So what do I want to do with this demo network? I want to filter customer routes and not accept my own routes on the inbound side. I want to take customers and have a community that I apply for customers that I'm giving transit to. I want to filter other routes that I really shouldn't be seeing. I'm not using route flap dampening. We didn't really talk about it, but in the first presentation I said, if you think that you need it, you probably don't, and if you do, then there are about 10 papers that you should read to make sure that you really do. You can really cause yourself a world of hurt by turning on route flap dampening. It was a nice idea, and again, there's a lot of things on the internet that were fallout from the days when routers had 60 to 40 CPUs in them that are not quite as big an issue nowadays. And you do want to allow customers some flexibility in how you advertise them. And I should probably update this to pop in a more regularized community system, but it's pretty simple, but it gives you the general idea of what can be done. So what do I want to do? I want to prefer customers, then private interconnects, then things I consider good public exchanges, then some places that I'm at, but I put a bag over the router port and then stick the cable in and then, you know, pretend that I'm not really there. And then I use, in this case, I'm using Confederations. We'll probably update this for route reflectors next time. I'm using loopbacks for peering. So I've got a bunch of interfaces. The slides are already submitted. I have some slight updates, but you can download them from the site. So I won't go over all the details there. I'm going to run OSPF internally to synchronize. Now, you can use iBGP as an IGP. Generally speaking, the IGPs like OSPF, ISIS, ERGRP are stable enough now that there's really no reason not to use them. The only thing that you don't want to do is cross the streams unless you're pretty familiar with how to do that safely. So redistributing between active routing protocols can get you in a world of hurt, but just running OSPF, typically not a problem. Do run authentication. I guess you're probably not worried about smarter hands wandering in and sticking a PC in and jacking into your OSPF, but still, good idea. I've seen a lot of people run OSPF on interfaces that they thought were private that turned out not to be. In BGP, I always recommend that you have an AS path access list that you know the number of, so when you have an oh shit moment, you have something that you can deny everything and one that you can permit everything. Typically, when you are in the middle of configs and you realize that even despite review you got it wrong, you don't want to shut the session down because you're advertising routes and you don't want to stop advertising them, but you may want to immediately stop accepting because you've just applied something and now you're sending too much traffic to an interface. So neighbor foo, AS, to out, boom, clear soft out, I'm done. Or soft in, I'm done. So in this particular case, we're using confederations in this example. So we have a fake AS. I find that it's helpful to set the router ID. Set it to a loopback if you've got a canonical loopback for that router. Better than just letting it float. Or, God help you, you actually have multiple routers that have the same router ID. That can get you into trouble as well. I've got a network statement that I'm creating. And in the simple world, you can create the network statement with just a mask. Here I apply a route map. So when I create the network, I have a route map. And what does the route map do? It sets the community 123, which says it's an internal route that is also mine. So in this case, I'm going to have two communities that match routes that I advertise. 123 is the one for ones that I originate, and 1200 is the one for my customers. And there's nothing that told me that I should do that except in the network that this was an example of. $1,200 was what we sold transit, for 100 megs, let's say, for. And 123, we just picked at random. So for public peers, I'm going to have a route map for inbound and outbound that's going to do the various sanity checks. It doesn't hurt to do next top self version, set the version to 4. I don't know, the last time I had someone try to speak version 3, I don't associate with Vinny Bono anymore, so that hasn't happened in a while. And soft reconfig. If you're not running route refresh, very important to enable soft reconfig, or all you can do is clear the session hard if you need to change the policy in an emergency. So the old way, does anyone still remember the inverse netmask dinosaur Cisco stuff? Anyway, you don't have to. There's 3 different ways you can talk about prefixes on the Cisco. You can use CIDR notation. You can use, 255, 255, 255.0. You can use slash. You can use that, or you can invert that against the ones and do it that way because Cisco's hardware used to love it if you did that, and their software was too lazy to convert it. So, if you see stuff like that, 0.0.0.255, you're not having a nightmare. It's just old Cisco configurations. So. The new way is you actually use prefix lists. The only really interesting thing there is if you don't specify anything at the end and you say /17, it means exactly /17. If you mean between a 17 and a 24, you basically have to say between a 17 and a 24. And you'll want to filter RFC 1918 space. You want to make sure that no one can advertise your routes to you. There is a time when that was important. I don't know what year the AS 7007 incident was, but there was a time that someone deaggregated the internet and started throwing back 24s to people's 17s. So, but also, let's say someone is maliciously trying to cause you trouble and hijack your TACAC server, your auth server. You don't want people to be able to do that. If you did accept that route and it was more specific than even any static route, then you'd have a real problem. And you probably don't want to accept things that are not at least 24s. You don't want to accept the default route from peers, stuff like that. From a public peer, I might have a route map that sets the Local-Pref one way. And then when I want to send transit, I've got a community list that says if at any point that I accepted a route, I said 123, which means I created it. That's what I think it means. Or 1200, which means it was from a BGP customer. Then I'm going to send it. And when do I send transit? I send transit routes to my peers. So I guess you could debate, does send transit mean send a full transit feed of the internet, or does it mean send my customers that are paying me to give them transit? So that's up to you to decide. And then you may have access lists that prevent you from letting someone leak by, you could either have a max prefix, or you may belt and suspenders say, you know what, I know that 3356 is probably not getting transit from Hurricane Electric. When I peer with Hurricane Electric, let me not accept certain well-known ASs. Now, it may be that I'm happy to have people give me free transit, but in general, when someone's giving you free transit, it's worth less than you're paying for it. So you probably don't want to be getting that over an exchange point via someone's, because you're probably not the only person that they magically decided to give it to. Private peers, you're basically, the main difference is you're going to have a route map that's going to set a different local pref because you want to prefer it a little bit higher. And so you'll set the local pref to 120. And again, you may also, in a simple config, statically on a given router, set a community that says, hey, I got it from this POP or this router, typically this POP, not this router, so that you can look for that community and see all the routes that you heard at that given location. And from customers, the key thing is you need to filter the prefixes. So you're going to have a prefix filter from that particular customer, ideally. And the route map that you apply is going to set the local pref higher than you use anywhere else. And if you want, again, in a simple static way, to be able to let your customers change how you advertise their routes, then you can come up with a community system that you tell people that says, hey, if you give me the community 15,000:44360, then I'm not going to advertise it to 4436. I'm going to advertise it 0 times. Or 2, I'm going to prepend it twice. Or similar things. These are all things that you can create, hopefully based on a sane system, and give to your customers. But you can do a more complex but created for you in regular way that gives people a regular way of looking at what country, what POP, what network what you heard it from, and how you'd like it to be blocked or AS path padded, or even, in some cases, what other communities. Let's say I buy from a provider that lets me set it to be a slightly depreferenced customer route or a higher pref customer route or even a peer route. I may want to give my customers the ability to change how that's seen at UUNet land. And so, again, you would implement communities that let the customers implement that. So search Nanite presentations for Steam version, and you'll find a number, I think, was 81 out of 120 or 220 will be that presentation. Backup transit, you can do things where you set up a peering session. Now, actually, we probably don't want the local pref here to be 140. But you set up a peering session where normally you're not giving them transit, but by saying additive, which you normally might not do on a peer, they can, if they have an emergency and need to turn it into a transit session, you can tell them, hey, just put 15,000:1200 on it, and I'll start advertising your routes. And I've seen a lot of different cases over the last so many years where people have given that kind of flexibility. So if someone has an emergency at some POP where you have a customer that you needed to go to, but you couldn't argue the business case to get fully redundant, you borrow a cup of transit so that you don't have to wake someone up in the middle of the night to have them configure it for you. So the other thing that I was going to show before we take questions was how to use Perl to mangle routes. So I'll take a quick poll again. How many people have used the screen command in Unix? Okay. The TypeScript command in Unix? Okay. And how many people know at least some scripting language? So it's actually really interesting when you hire people a lot of people that are router people, if you ask the question, please tell me how many different ASs present behind this other AS, they wouldn't know how to answer the question. But they actually have the skills to put it all together if you just be a little creative. So I've got screen running here. Why is screen important? Well, if I'm going to dump the routing table via simple methods, that's going to be actually, it'll be at least 300,000 lines. It'll be 30 megabytes that you don't want to have scroll across your screen, especially if you're on EVDO or, God help you, something slower like AT&T's network. You don't want to have that happen. So set up a screen session, already set it up, so that when you start it firing off, you can immediately go away from that window If you just change tabs in SSH, all that's going to be coming to your machine, and if you're running an Atom, again, God help you. So now what do we want to do? Script BGP1 is just a Unix command that captures everything that it sees to a file. Telnet to a router. Telnet to a router. And I'm going to do turlen 0, which means don't show me the more command every so often. And then show IP, BGP, neighbor, some full feed routes. And control A space, and now that's all happening in the other window. So if we're impatient, we can run the finger under the faucet. This is an octa-core and a Halem, and it's a SUP 720, so it should finish reasonably soon. So you look at the file, and now if you edit the file, it's going to have these control M's. If you're really antsy and you hate seeing that, there's a VI command I can give you that will eliminate them. :1, $S/ control V escapes control characters, and then control M, and that'll, boom, make them go away. But it doesn't really matter, because the whole purpose of this is you're not going to look at it by hand and use /. You're going to write a program that's going to look at this and tell you something. So what might we want to see? We might want to count how many routes that we hear that are right beyond 4436. Actually, I'm not going to change it because it is being currently updated. Yay, we're done. So I'm going to quit. One very important thing is remember to exit the shell. Otherwise, as you write the program, it'll be in the file. And there are strange things that you could do to cat the file and then infinitely append the file to itself. So when you do the TypeScript command, it creates a new shell. You have to exit the shell to stop writing to the file. So now I want to see how many next hops, how many routes I hear from each AS that are in front of 4436. So count.pl. Perl, how many people know C? Perl? For the C guys who don't know Perl, nice thing about Perl is it's got associative arrays, which we will use, and the ability to blow apart strings, which we will use. Other than that, it's possible to write Perl code that looks like awk, and if you do, you work for me, you probably won't be for long. It's also possible to write Perl code that looks like C, so try to do that if you learn Perl. So what I'm going to do is I'm going to look for space 4436 and then some numbers. So \d matches a number, and then plus matches a string of numbers. Now, it's not relevant for this application, but \d does not match the minus sign, which can be interesting if you're actually adding real numbers, not these fake numbers that happen on the internet. And then I'm going to say that. So I'm building an associative array indexed by $1 is this thing in parentheses, which is the AS 646. In this line, it would be 6461. The autonomous system number, the set of numbers after 4436, I'm going to increment the counter for that. And then all I do at the end is for each AS in that associative array, and theoretically, that should count it, which it did. And then I can count and see how many different, so we can see that there's a bunch of routes coming from 3549 and, on up. So I can also, if I was curious how many routes were externally originated, internally originated, when you're looking at, if you don't have a NetFlow or SFlow collection, basically your tool is to move traffic for load balancing, not performance, but for load balancing is to figure out roughly which ASs to grab as you build route map lists and move things around, this is a way of simply, without having to look through your eye, look at what routes are from where, from what providers, and getting some data. But once you have it in a file, you can actually write other programs to look at it. So very simple stuff. I did not get the Catalyst set up. Maybe next time we'll have a, next BGP panels will be a spirited debate about best practices in BGP, and then maybe we'll also do a influencing, load balancing, and breaking the internet live on stage presentation. But any questions? Yes.
Yeah, with the new feature where you don't need the soft reconfig, so would you say that it's pretty good to turn that on and wherever it's available?
Yeah, I think it is correct. So Richard, is it on in most configs?
So there's actually in new iOS code, which if you're talking 6500s, which is probably what most people use, 12.2.33, anything that's like SXH or SR, there's a feature that will turn on soft reconfig only if the peer does not support route refresh. And if you're still peering with someone who does not support route refresh, you have bigger problems.
Right. So if it supports route refresh, you don't have to actually turn it on. It'll be negotiated and used.
Okay. So I guess the key thing I was getting at, does it make, I guess if it automatically detects it and only uses it if it's not there, it doesn't hurt to just leave it on then.
My thing is
All right.
Yeah. Or belt and suspenders. Other questions, comments? I would encourage you guys, not specifically just to give feedback saying that this talk sucked, but if you have specific things that you'd like to see covered in the routing realm, to suggest them, because otherwise no one knows what you guys would like to hear. And it's always a little bit of a, it's a little bit interesting, you know, planning the audience, because, for example, in Dominican Republic, we gave basically this presentation, but the only people who went were all people who ran, you know, even bigger networks than I run personally. And so that was a little bit, what that degenerated into was a little bit of a best practices debate about how you do various things. I think there's definitely an audience for at least some basic BGP intro for people, but in terms of more advanced topics, it would be useful to hear from people what they'd like to hear. So, thank you. Come to the community meeting so that you can make fun of people or say random, weird, annoying things. Or if you've never been to a community meeting, then you could observe these things and gain some understanding about the Nanog community.